Welcome to the channel, guys. Today our video is stability on the polar plot. So let us start. This is our fourth video in the series. If you have not watched, you can watch 3 videos, #1, 2 and 3. This is our fourth video. Okay, so let us start. Stability can be determined by calculating gain margin and phase margin, that is GM is gain margin and phase margin. Okay, you know this stability, this is the method how you calculate stability. So stability you can only determine from gain margin and phase margin. Now our second point is gain margin is calculated at omega PC. This is the definition of gain margin, that gain margin is always calculated, guys, at omega PC, that is phase crossover frequency. Phase crossover frequency, that is at this frequency the phase is minus 180 degree, and phase margin is calculated when magnitude is 0 dB. This is the definition of phase margin. What is the formula of magnitude? 20 log K. Okay, that is the formula of magnitude is equals to this magnitude value should be equal to 0. At that time you get your phase margin, that is this can be only be 0 if K is 1. Definitely. Why? Because log 1 is 0. Therefore at this time K will be 0. Okay, so we go to the third point. Now guys, just give me 5 more minutes. This diagram is very easy. After 5 minutes you will be able to draw this by yourself and explain it by yourself. Okay, this is nothing. Just give me 5 minutes. So do not have any confusion or any question in your mind that, oh, what is this? This is nothing. Okay, so we go to our third point. Let us consider a typical polar plot. Fine, we are considering that. Let us, some polar plot is this blue line over here, and we draw a unit circle around a polar plot. That is, this is our polar plot and we are considering a unit circle. What is a unit circle? Whose radius is 1. Radius is 1 means from here to here, here to here, here to here, and here to here the radius is 1. That is a unit circle. Okay, this is the method. We are just considering a unit circle around our polar plot. Fine. Now what happens? What they are telling is, observe carefully at point A. Okay, they are considering this as point A. The polar plot has angle minus 180 degree. You agree, right? At point A, the angle is minus 180 degree. Why? Because you know that. See, here it is 0 degree. At this line, it is minus 90 degree. At this line, it is minus 180 degree, right? And at this line, it is minus 270 degree. We all know that, right? So at point A, what is the angle for this point? Minus 180 degree. Definitely, you know this if you have watched previous video, and if also you have not watched, this is very obvious thing. Okay, there is no doubt in it. Now, point A is a phase crossover frequency. Point A is a phase crossover frequency. Why? Why it is phase crossover frequency? Because according to definition, guys, this definition you should know, because at omega PC, phase is always minus 180 degree, right? So as point A has angle minus 180 degree, therefore here we get omega PC at point A, right? This arrow is showing you omega PC. Now there is one formula that at omega PC, right? At omega PC, you can compare, you get gain margin, right? So at omega PC, your gain margin, that is at point A, your gain margin is 1 upon x. This is a formula, right? You can do nothing in here because this is a formula. You have to accept it. If you want to find the stability of the polar plot, your gain margin you can calculate only by 1 by x. Okay, now there is one very important condition is x should always be less than 1. That is, guys, x should be less than 1 means 1 is in magnitude. That is, they are telling that if this is your polar plot, then this much length, barabar, from here to here, like this, from here to here. So this length, you suppose it as capital X. So it should always be less than this length, because this length, if you consider magnitude, will be 1, right? From not this, from here, from center to here, this length. If you know this length is 1, why? Radius is always positive. Radius is 1. Why? Because it is a unit circle, it is a unit circle. So they are telling that your this length of x should always be less than your radius 1, right? This is your 1. The point here is -1, guys. Do not get confused. Radius is always 1. Radius is always positive. So they are telling that whenever you plot a polar plot, your polar plot should be inside this -1. Okay, do not get confused with this -1 sign. -1 is a scale, right? But when you consider it as a radius, this radius is, okay, here, right? This radius is always +1. Radius is always +1. I hope, guys, it is clear, right? The length is always considered positive. You do not consider it as -1, right? Yeah, point is -1. So your polar plot should be inside this pink line. If you see, if this length is 1, your this blue is your polar plot, should always be inside this pink line. If your polar plot covers this -1, then the stability is, there is no stability. Barabar, stability only exists if x is less than 1, right? Now this point is very clear, right? Okay, so we go to the next point. We will get magnitude 1 at point B. What this point is B. Just draw from here, just draw the dotted line and the polar plot. I repeat, the